name is Colleen Lishu, and in video we're going to be going through how you extract data from publications and kind of what you want to look out for when you are gathering data for interpretation of variants. And go through this fairly quickly. I've pre-reviewed and highlighted all of these papers, but I would encourage you, when needed, to pause the recording so that you can read the relevant content yourself. Jump in. So I have a list here on the upper right-hand side of your screen of some things that you typically want to be looking for when you're extracting data from a paper. So how many unrelated cases had that variant? How many unrelated cases were analyzed total? How were the subjects ascertained? Is the clinical phenotype of the cohort overall of the individual with this variant specifically? What is their ancestry? If we're going to feel like mine, cardiology, where there's local heterogeneity, you're going to want to look at what genes were evaluated. Did they have all of the genes that you want to have evaluated to know that we're not missing a variant in another gene? Did they report any segregation data? If so, what are the specifics and strength of that data? Is there molecular functional data? Did they report any control data? And importantly, is there any chance that there's overlap with other data sources? Get to counting cases for evidence for pathogenicity. We want to make sure we're not counting a case multiple times. So we're going to look at a handful of papers, starting with this paper from Ray Hirschberger's group. They studied familial dilated cardiomyopathy, and this variant specifically in BAG3. If we're open here, we might start off by getting a sense of the paper from reading the abstract. You don't necessarily have to read the paper thoroughly to get the data that you want. So there are certainly cases where that would be important to do. This is a paper where they take a large multi-generational kindred, multiple affected with dilated cardiomyopathy, and used a genome-wide approach of exome sequencing as well as copy number variant analysis. Identified a new gene for dilated cardiomyopathy, BAG3. They then went on to sequence BAG3 in other families with dilated cardiomyopathy, and one of those families identified our variant in question. So it gives us kind of lay of the land for the paper. Now we're going to dive in and get the specific data that we want to see what evidence it provides for pathogenicity for or against pathogenicity for this variant. Some related cases had the variant. You want to look for a table that lists the variants that were seen, or you may F through find your variant. Here, there's this table, variants identified by sequencing BAG3, and here's our variant, which I've highlighted. You can see we observed this variant, and it looks they have a case count here, so I can't get that from this table. So I want to see how many cases have variant, and they have another table, very detailed data on each pedigree, the variant they had. So we're going to do a quick look through there, and we see variant here, and so this variant was observed in one. Of a total of 311 unrelated cases. How subjects ascertained, you can often find that in the methods, the beginning of the methods. If not, it might be the beginning of the results. And in this case, I was not able to determine exactly how they were ascertained. So there was IRB approval from 2 institutions, one in Oregon and Miami, so they may have been recruited that way. Another way of thinking about how they're ascertained is, what was the target population? In this case, the target population was dilated cardiomyopathy, probands with dilated cardiomyopathy. Important to know, which gets to what is their clinical phenotype. So the clinical phenotype for the cohort overall is dilated cardiomyopathy. Go back down to that table and see what they provide for the clinical phenotype for this variant in particular. So we have 3 individuals in this kindred. We can see their age, their gender, They all three have DCM. Two also have atrioventricular block and some particular EKG patterns. You can extract from this table some of the key phenotypic data. So it's nice. This is a paper that provides thorough individual level phenotype data. We don't always get that. What is history? I have looked through the birth in a variety of locations, and I was not able to find ancestry for these individuals. It's not written in this table. It doesn't look like overall ancestry was reported either, so we don't have that. Unfortunately, why that's important is we want to be making sure we have controls that match the ancestry of our patients. So, for example, if this was a Filipino family and we don't have any Filipino controls, we'd want to be thinking about, can we be confident that this is a rare variant? So asking about what genes were evaluated. In this case, for this paper, these individuals had already had sequencing of 15 other dilated cardiomyopathy genes. They wanted to get into the specifics of which genes, make sure there weren't any major ones missing. I would go look at those prior references. There again is you want to make sure that they're in a disease locus heterogeneity. There aren't other, you're not a highly prevalent gene, so you could be missing another pathogenic variant. Molecular functional data, they did do some functional work in this paper. However, using ZFISH, however, it's a knockdown, so we don't know that it's necessarily applicable to this missense variant, and they didn't do any functional data specifically using this missense variant. What about controls? We did look at controls. Investigation also included a total of 355 population controls, and it gives you that most of them were white, male and female, roughly. Specifically want to know, though, was our variant absent in controls? Just because they studied controls doesn't mean they looked at our variant in controls. So you want to check that specifically before you idea that your variant was absent in controls. So work carefully and try and confirm that. Here we can see that this deletion was not present in the calculation. The result section when they sequence their families. Identify questions in 7 unrelated probands that were absent in 5 in-house population controls. They also cite additional controls from Seattle-Seq. Important to notice here is that they didn't think about phenotyping the controls. So these are presumed healthy individuals. They have not had a cardiology evaluation to rule out cardiomyopathy. Is there overlap with other data sources? So we would only count a case twice. So the thing that I might notice in this paper was the fact that when they talked about their population, they cited other papers. They have reported on the cohort before, so I'd want to be watching for that. So would want to take note of the institutions that were involved and the key authors that were involved. And so if I was reviewing other papers on this variant, I would want to be looking for overlap in institution, authors, location of ascertainment, etc. Okay, move on to our next variant and paper. So again, we're doing all cardiac because I'm a cardiac counselor, but a lot of the principles are generalizable. We're going to be looking at a long QT gene, KCNQ1. So on here, my list of variants. We're going to be looking at this missense variant, and we're going to look at 2 different papers. So start with Flosky et al. 2000. First, just to lay of the land of this paper, let's take a look at the title and abstract. Mutations in long QT syndrome genes. This is kind of, I know, historically early in long QT genetics, so it may just be a case series or a single cohort kind of describing the genetics of their cohort. This is to screen a pool of 262 unrelated individuals with long QT syndrome for 5 defined genes. So that would include the key genes, the 3 genes. We wouldn't be missing anything critical, so it's not as complete of a gene list as we would have now for long QT. Okay, so yeah, expected. It's just here's the genetic landscape of this cohort. And so how many unrelated cases had our variant? So I want to look for data on our variant. Is a table of KCNQ1. This is a synonym for KCNQ1. And we see here's our variant with single letter amino acid nomenclature. And it was seen in 2 families in this study. So 2 related cases. Interesting that they say family, which makes me wonder about segregation data. We'll come back to that in a second. How many unrelated cases were analyzed? We already previously grabbed that in the abstract. How were the subjects ascertained? Individuals obtained in clinics from North America and Europe for long QT, based on QT and symptoms. This study is on proband, so we know they're all unrelated. Describing here individuals basically evidence of long QT syndrome. What is clinical phenotype? No, so all the cohort had long QT syndrome, but what do they say about my case in particular? No phenotypic data in this table. I'm going to do a quick to see if they come up anywhere else in the paper. For a patient ID, and then you would search by that patient ID. I'm going to do a quick scan of all the display items just to see if I see any individual phenotypic level data. So I'm going to look supplement. There's no supplement to see if they concluded there. So it looks like there may not be any individual phenotypic data. Let's see, for phenotypic data, we know that to be study, a proband had to have long QT syndrome. And then see some summary data by gene here. So for KCNQ1, average QTc of 493, certainly consistent with long QT syndrome, 78% symptoms. They define symptoms here. So evidence for this being a cohort with long QT syndrome. No individual level data. What's straight, from the scan we just did, I can be pretty confident there is not individual level ancestry data, unfortunately. And with ascertainment in North America and Europe, we would not necessarily, we wouldn't be able to make any conclusions about an individual's ancestry, since they have, both of those locations have mixed populations. What gene are evaluated? We already went over that. Is there any segregation? Given what we've seen so far, I'm going to guess not. But we can start segregation. No. Given my view of this paper and our quick scan of the display items, I did not see any segregation data. So you would say they have some because they say number of families. Let's see what that footnote is. No, for long QT families. Any molecular or functional data based on the abstracts? Doesn't look like they did that kind of work. And did they study any controls? So variant had to be not present in greater than 400 control chromosomes to be defined by them as a quote-unquote mutation. So I would interpret this as our variant was not seen in 200 control individuals, and no phenotyping on controls was done. Overlap with other data sources. So one thing I'm conscious of simply from working in the field in long QT syndrome is that there are a lot of long QT registries that get published. Data on those cohorts get published again and again. And look at these key authors, so these folks are heavily involved in those registries. So these individuals involved in these registries and registry, and then Sylvia Fiore and Peter Schwartz also have European cohorts that may have been published again independently. So I'd want to be looking for those names, looking for those centers that they come from, and might even use the author's affiliation list to give me a sense of the centers that the cases were recruited from, likely though not definitively. So let's move on and look at the next paper. The first you'll notice is that the first author is Art Moss, who was one of the authors of the last paper. So again, that idea of being careful about overlaps. Let's just look at that really carefully. So Moss, I'm looking which authors between these two papers. But is not definitely indicative of overlapping cases. So Moss, Tobin, Bint, that's it. On a quick scan, it could be missing some. So that's important for us to be thinking about. Is there could be overlap here, so let's watch out for that. And, we're not going to this paper in detail. What we're going to do in this paper is try and assess whether or not there is overlap. So let's first just look at our variant. So here variant, and they have, it's been seen in 18 subjects. So let's back up and just look at the track and get a sense of what this paper was about. So this is a paper trying to assess genotype-phenotype correlations within the CNQ1 gene in 600 patients with QT with case invariants from 101 unidentified families derived from the U.S. portion of the International Long QT Registry and then the LENS Registry. And the Japanese Registry. So again, there's a bit of a hint that there could be a overlap between this publication and other publications. One, because of ascertainment of these cases, and the other paper on genotype-phenotype correlations, it may not be the first time that these individuals have been published. It's sort of a on the mutations themselves specifically, but digging deeper into the mechanisms of disease and not. So that's kind of got me thinking about that. And then the fact that it's 600 patients in 101 probe identified families means when we go look at this case and it says 18 subjects, we don't know how many of those are unrelated. Let's see what this little footnote means. Irrelevant for us. So a couple of things here. I would be hesitant to count these cases as being necessarily independent from the cases that we just reviewed in the Splasky et al. Paper, given the potential overlap in registries, even though the Splasky paper doesn't call that out specifically, and the overlap in multiple American authors. And then in addition to that, don't know how many unrelated cases to actually count because we don't know across families these 18 individuals were. So that's the kind of thing you have to watch out for. On to our next paper. Look at related but different variant. So the same codon but a different amino acid change. A time instead of a serine. And my Google search, literature search, databases, etc. Brought me to this paper. So let's take a quick look at what this paper is. So it's a series from one of the LongQT genetic testing companies. So it's basically 2,500 unrelated consecutive cases that they saw over X number of years, and it's their sort of compendium of the variants that they observed. The unrelated cases had my variant. The variant data is in a supplement for this paper, so let's go look at that supplement. And here is the KCNQ1. You can see the column headings there, and we go down, and here's our variant, and it's been seen in one individual. Data total of 2,500 unrelated cases, so 1 out of 2,500 has this variant. We know subjects were ascertained again. It was from referral for genetic testing or ordering of genetic testing. What is their clinical phenotype? So do we have individual phenotypic data? Not in this table. I go through the rest of the paper, the supplement, and the main text, and there's no individual phenotypic level data. So then I'm going to see what summary phenotypic data is available. Samples are accepted for genetic testing and included in this retrospective analysis regardless of the ordering physician's index of suspicion or pretest probability of a clinical diagnosis of long-QT syndrome. So that's kind of like, okay, so there are probably going to be some people in this sample who do not have long-QT syndrome. You expect that when ordering using a sample based on genetic test ordering in general, they could have selected for only the cases that had strong evidence, but what they're saying is we took all comers for this analysis. So in the phenotypic data they provide, forgive me, I didn't highlight that. Oh, so one noticing right is that their results section, the yield of testing was 36%. 30% of cases had a rare variant in one of the long-QT genes. We know from prior literature that the yield for long-QT sequencing is more like 70%, maybe 75%, depending on your case selection, when you have people who definitely have long-QT syndrome. So what it suggests to me is that only about half of these individuals, maybe a little more than half, actually have long-QT. So that will make me think about my case, the one case that has this variant a little differently, because really in some ways they count as sort of half a case or 60% of a case, because we don't know whether they had long-QT. And for one individual in this cohort, there was probably about a 50 to 60% chance based on this yield that they'd actually have long-QT syndrome. Other thing I am conscious of, I don't have these papers that show you, but I know that who's the senior author on this paper has used some of this data set in subsequent papers. So if I came across those for this specific variant, I want to be looking carefully at the ascertainment to see whether or not it overlapped with this data set from this genetic testing company. So, some of the keys you want to be looking for when extracting data from papers. Certainly not an exhaustive review, but some of the critical things. And you found this helpful.